Hello friends, welcome to the learning curve. Now look at this question. The question is x to the power y minus y to the power x is equals to 17 and we have to find the value of x and y. Let's see how do we proceed. Here the base is x, exponent is y and the base is y and the exponent is x. So what we are going to do, simply we'll just multiply and divide both the exponents with 2. So we can write it as x to the power y whole to the power 2 upon 2 minus y to the power x whole to the power 2 upon 2 is equals to 17. Further, you can write it as x to the power y upon 2 whole to the power 2 minus y to the power x upon 2 whole to the power 2 is equals to 17. Further, you can write it as, just assume that let m is equals to x to the power y upon 2 and n is equals to y to the power x upon 2. Now put these two values in the equation, so you get m square minus n square is equals to 17. Here you can apply the algebraic identity, that is a square minus b square is equals to a plus b, a minus b, right? So you can write it as m plus n into m minus n is equals to 17. Now we have two terms equivalent to a single term, so we'll just break up 17 into its prime factors. So it is 1 into 17 and 17 into 1. Now according to our assumption, m is equals to x to the power y upon 2 and n is equals to y to the power x upon 2. So here m is greater than n and they both are greater than 0. This implies that this is discarded because 1 is smaller than 17. Since this is greater than m minus n, so this equality is valid here. This implies m plus n is equals to 17 and m minus n is equals to 1. Now we have two equations. Now we can solve these two linear equations applying the elimination method. So for that, just add up these two equations, that is equation 1 and equation 2. So you get here 2m is equals to 18, right? This implies that m is equals to 9. Now putting this value of m in equation 1, that is m plus n is equals to 17, put m here, so you get n is equals to 8. Now according to our assumption, we have m as we assumed that m is equals to x to the power y upon 2. So just put the value of m here, you get 9 is equals to x to the power y upon 2, or you can write it as x to the power y upon 2 is equals to 9. Now apply squaring both sides, so you get equals to 9 square, or you can say x to the power y is equals to 9 square. This 9 can be splitted up as 3 into 3 whole square, or you can write it as x to the power y is equals to 3 square whole square, or x to the power y is equals to 3 to the power 4. Just call it equation 3. Now similarly, as we assumed that n is equals to y to the power x upon 2. Now put the value of n here, you get 8 is equals to y to the power x upon 2. Apply squaring both sides, you get 8 square y to the power x upon 2 whole square, or you get 8 square is equals to y to the power x. Or you can write it as y to the power x is equals to, just break up this 8 as 4 into 2 whole square, or y to the power x is equals to 4 square or 2 square, or 4 square into 4, and this can be written as 4 cube. Let's call it equation number 4. Now as we compare this equation 3 and equation 4, you see that x to the power y is 3 to the power 4 and y to the power x is 4 to the power 3. This implies that x is equals to 3 and y is equals to 4. Now let me check these solution by putting these values in our equation. Just put these values in the given equation, that is x to the power y minus y to the power x is equals to 17. So we have x is 3, y is 4, minus y is 4 and x is 3. So we have this is 81 and this is 64 is equals to 17 and 17 is equals to 17. So our required solutions are x is equals to 3 and y is equals to 4. I hope you understand the question, and if you like it, kindly subscribe my channel. Thanks for watching.